Bismillah ar-Rahman ar-Rahim. I think we have stopped here last time. We talked about the intermediary devices. So first we talked about what host is, and host can be a client or the initiator of the communication, or it can be a server who is the one who's providing the service to the clients. Apart from the hosts, which are connected to the network, there is the intermediary devices, which are the devices that facilitate the connectivity between the hosts on different networks. And these intermediary devices include routers and switches and hubs and things like that. So all these devices we'll study in details in the course. Other than that, from the physical layer perspective, at the end of the day, our data is converted into analog signals. And these analog signals will travel over a specific media, specific types of media. And the types of media that we commonly use are either metallic wires, and there are so many types of media in that category, or it could be a fiber optics, or it could be wireless. So these provide categories of possible media that we can use to transfer our data over the internet. Each one of these has different characteristics, which we will study throughout the course. Has some drawbacks, some advantages, some disadvantages, and so on. So we'll study that in details throughout the course. So some of the criteria based on which we can decide to use one of these possible media is the distance that the signal can travel through that medium. For example, for coaxial, you know the coaxial cable, which is the one that we use commonly for TVs, right? So of course this one uses some type of electrical signal, and the electrical signal can travel over that coaxial wire for a specific distance. Okay, and this distance is usually around maybe 500 meters. Whereas if we use the metallic wires that we use for our Ethernet connections and stuff like that, this cannot go more than 100 meters. So if we want to have a distance of more than 100 meters, then we have to put some intermediary device in between to expand the range, okay? Whether this intermediary device is a hub or a switch or a router or anything, okay? But of course, the coaxial cable has certain advantage in terms of distance over the other type of wired or copper wires. So the distance is one of the important aspects based on which we decide which medium to take. Also, environment that it works in. So we cannot use, for example, fiber optics in a lab like this, because fiber optics is made of glass, right? So if you bend it sharply, it will break. It may actually break. So it's not feasible to use this type of medium in a lab like this, where you have to facilitate the connectivity in every single seat. So you have to bend it back and forth or something like that. So it's not feasible to be used in labs where you have so many obstacles and things like that. Also bandwidth. Bandwidth is like, think of it for now as the width of the pipe. So the medium think of it as a pipe, okay, where the information flows through a pipe. And the bandwidth is actually the thickness of this pipe. So of course fiber optics has a thicker bandwidth or a thicker width compared to other types of medium. Okay, even wireless, you can think of it as at the end of the day, it's a pipe through which the information flows. Except that this pipe is actually the air, the vacuum. So Of course, wireless has different bandwidths depending on so many things. So it does not have a single bandwidth, but coaxial cable has certain bandwidths. UTP cables or the other type of wires have certain bandwidths and so on. So depending on the bandwidth, so we would love to use fiber optics in just about every single connection. However, this is not feasible due to some other aspects like the environment that it works in, the cost, which is the one that we'll talk about next. So fiber optics is the most expensive by far. So we cannot just use fiber optics in every single. Although now we have fiber at home, but again, these fibers have to be used within a limited distance, and then after that you have to use switches and things like that, which connects you to the service provider like Ooredoo or something. But you cannot just dig, fiber optics everywhere. It's not feasible due to the cost and due to the environment.
Where can we know that copper, for example, is more suitable in this case than the fiber optics or wireless?
Well, depending on this criteria that we're discussing now. So if we are in a room like this and we want to, for example, have like a workstation in every single seat, okay, then the best option would be the UTP cables, okay, which is what we have in our labs. Every single seat has UTP cable which connects to a switch, a centralized switch in the lab, and then this switch will connect to the backbone of the network. We cannot use fiber optics, of course, because of the bending and things like that, and due to also sometimes the cost. We can use wireless if we want to simplify the deployment, so we don't have to use wires everywhere because it's not convenient, and you have to jump over the wires every now and then, so it's not convenient. So sometimes we opt to using the wireless, right? But the problem here is that wireless does not have the same bandwidth like UTP. So depending on the speed that you want, you may have to use UTP in certain cases, especially if the devices are not moving. If the devices are not moving and we care about speed, okay, then in that case it's better to use wires whenever it's feasible in the environment. And for copper wires, you can bend it easily with no problem. So you can sort of live with that.
Yeah. Okay? So it doesn't depend on the information that is transferred.
No. All types of information, okay, can travel on all types of media. There's no restriction when it comes to the type of information that you want to send. There is some restrictions on the bandwidth, which limits the speed of sending the information, and that affects the quality of service. Remember, so if the bandwidth is low, then the speed that we can send the information through that medium is low, in which case the quality of service may be bad, and it reflects on your quality of experience. When you watch, for example, a video on YouTube, you see some pauses and some interrupts here and there, which doesn't look good. Okay, so that's affected sometimes by the bandwidth, and that's why the bandwidth is one of the most important things. Maybe cost is not a factor, especially nowadays, and especially in the region here, is not a factor, but definitely environment is a factor, and of course the bandwidth is a factor. Okay. And also the cost includes the cost of the raw medium, how much distance, like per meter, the cost per meter, and also the cost of the connectors, because at the end of the day, you have to put some connectors in order to connect these wires into workstations, into other switches, routers, and so these types of connectors also sometimes it would be very sophisticated, right? And it requires very special handling and very careful, setup, which might cost a lot. So especially for fiber optics, the connectors are usually very expensive because you have to do it very carefully and it's very sensitive. It's usually costly. Okay. Okay, so now we discussed hosts, intermediary devices, and the media. Based on these three things, for each one we have, some types of, like host, we have client, we have server. Intermediary device, we have routers, we have switches, we have hubs. For the medium, we have fiber optics, we have wires, we have wireless, and so on, right? So, so you can group, different types of these and connect a network. So now we have a full network. So even the network itself has different types depending on how large the geographical area that the network can cover. Okay, so we have the first type of networks, which we call local area network, and from the name, it's clear that it spans a local area, which is limited geographically. Okay, so we can think of a LAN, like one lab would be a local area network, which connects to another LAN in the lower floor or something like that. And these two LANs are connected through a router, and then this router is connected to the main network of the university. So a local area network usually spans a small geographical area, and it's covered by one single. It belongs to one single organization, that's for sure. It's controlled by one single organization, right? And these LAN devices usually include switches, routers, and what we call multi-hub switches, which is another type of switches. So so once you connect group of hosts and a switch to a router, then a router will be used to connect one LAN to another. Okay, so once you connect, so a router, you can think of a router as the termination of a local area network. Okay, so a router is used to connect two LANs together. Within a certain LAN, you can use switches, you can use hubs, and we'll talk about this in details later. So WAN, or wide area network, and again from the name, it's clear that it spans large geographical area. It can cover multiple buildings and multiple like sites. Usually it's covered by one single service provider. It can cover multiple organizations like QU and Education City and things like that. These each of these organizations, they would have multiple LANs, and these LANs are interconnecting together through one service provider, who's Ooredoo, and the service provider now hosts this WAN, or wide area network, that spans multiple organizations. It spans a distributed geographical areas, which spans maybe a country, the whole country, or something like that, or cities or group of cities, and it's covered usually by one single service provider. Okay. The service provider interconnects these LANs together, and the interaction between multiple service providers form multiple WANs, okay, or multiple wide area networks, which we call it the internet. So the internet is a group of is an interconnection of multiple wireless area networks, which again interconnect multiple local area networks. Okay, got it.
But it goes with the same concept of like the same organization having small LANs connected together.
Okay, yeah. So
it goes with the same concept, but that is just with under an organization, and there is under like service provider.
I don't get the question.
It's the same concept. Like both of them, even one is about having different LANs connected together.
Yes, maybe what you mean is like you have one organization which is distributed in multiple buildings. So each building is covered by one local area network or more, one or more local area networks, and these are interconnecting together to form a wide area network. And this wide area network is connected to the service provider. But in general, wide area network can span more than one organization.
So it's just like to consider it as a wide area network, we have to covers a huge distance.
Yes, huge distance, huge geographical area.
But like the same organization, even if we have different plans, we can't really call it one because it's the same building next to your place.
It's a gray boundary, really. So a local area network is one single network which connects to a router. Once you have multiple LANs, you can call them WAN. Okay, even within the same building. Okay, multiple LANs is actually a WAN. Yeah, so a WAN can actually cover one single building to like the whole city. Okay, but it has to be covered by a single service provider. Okay, that's the main issue. Once it's a network spans more than one service provider, then this is the internet. We don't have any other category. Okay, so the internet is just an interconnection of multiple WANs that belong to different service providers. Okay, so these networks now, they form LANs and WANs, and one of the most important things, which is what we have discussed in the beginning of this course, is what we call protocols. And protocols, as we said before, it's the rules of the game. So a protocol is a group of rules that govern the communication. Okay, and we have talked about a certain example. If we start any kind of conversation together, like two people are starting any conversation, so we have to agree on certain rules. So first we say Assalamu alaikum. So we start, by saying Assalamu alaikum. So we initiate. We know that we want to talk to each other. If I tell you Assalamu alaikum, then this means that I'm prepared to talk to you. If I turn my face and go, then I'm not prepared to talk to you. Something like that. So once we agree that we want to talk to each other, then we have to agree on the language. What language are we going to use? And so on. So that's the protocol, right? So same thing in the network, we have to establish these protocols. And as we can see from this graph here, is that the number of protocols that are used in the internet is just huge. Millions of protocols. So some of these are medium independent. They don't care whether you're using fiber optics or something. Some of them, they do care whether you are using fiber optics, or some of them, they work only for client server. Some of them, they work for peer-to-peer. Some of them, they work in a specific routers, but not the others, and so on. So the map of these protocols on the internet, this is just a subset. All these are just a subset of the protocols that we use nowadays. And you have to appreciate the fact that as we speak, there are tons of protocols that are being released and studied by people in different universities, in different organizations, and things like that, to facilitate the communication in a specific type of network, using specific types of devices, and so on. Okay, so there are millions of these. So we can agree that a protocol is nothing but a set of rules that govern the communication. That's it. That's what we need to know about a protocol for now, and we'll talk about many examples of these protocols, how they are being used, what are these rules, and things like that. A protocol suite is nothing but a group of protocols, more than one protocol, which they can interact together to form a specific network function. Okay? They can interact to perform a specific network function. So for example, when you click, if you have watched the video that I posted on Blackboard, the Warriors of the Net video, you can see visually that when you click on the internet, the information has to go through different, layers. In each layer, you have a specific protocol that takes this information, it adds something to it, it sends it to another protocol, which again takes this information, adds something to it, and it gets sent, over and over again. And every protocol, they add something to it, which means that it interacts with the other protocol in delivering this information to the other side. So if we have multiple protocols that interact together by contributing to the delivery of this piece of information to the other side, then we call this set of protocols a protocol suite. So a protocol suite is an interaction of multiple protocols to perform certain network function. Okay? So that's an example. So when you click on the internet, this is the exact same example that's visualized by the video. So when you click on the web, you actually create some kind of content. This content could be anything, and here I put my signature as like a web content. And this web content goes into this data. And again, it gets represented using, again, ones and zeros. Okay, so now we have, using the encoder. The encoder will get this, will convert HTML into, at the end of the day, into ones and zeros. So these ones and zeros will use some kind of HTTP, and we all know HTTP. At least we know how to type it. We type it, and so that's we actually, when we type HTTP, what we do is that we trigger a protocol called HTTP. Okay. So this protocol, what it does is that it adds some header, and you can think of it as, I want to send a mail to a particular person, okay, on the other side of the planet. Okay, so what do? You just get an envelope, you write a letter, and then you put this letter in the envelope, okay, and then you put the address. That's what happens here. Okay, so HTTP, it adds some header which contains important information, which will be needed to deliver this information to the other side. Okay, and this protocol is in a certain layer, and we'll talk about layers after that. So the delivery of information over the internet is not as simple as sending a letter, unfortunately. So it's much more complicated. So you have to have, you can think of it as you have to put an envelope inside another envelope, and which what we call encapsulation, which we'll talk about in a minute. So HTTP adds some information to the data and then gets sent to the lower layer. And then there is another protocol called TCP, which again takes this data and adds something to it and sends to the lower layer, and so on until it reaches to what we call data link layer. In the data link layer, the next step is the physical layer, and the physical layer does not deal with ones and zeros. So starting from this point, we have to convert everything into an analog signal. So that's why we don't have any. So in the physical layer, we have analog signal. We don't have ones and zeros anymore. Okay. So the encapsulation or the envelope process stops at the physical layer. And the physical layer, it has to be converted into an analog signal, which we will study later in the course. Okay. So this is the application layer, and this transport layer, network layer, data link layer, and then the physical layer. We'll talk about each of these layers. So the process of delivery goes into what we call encapsulation. Encapsulation is the process of adding information to the data and then putting it in a protocol data unit. We call it a protocol data unit. Okay, so this is a protocol data unit for the application layer, and this is a protocol data unit for the transport layer, and so on. Okay, so the encapsulation is the process of adding a header to the data or any previous set of headers. Okay, so here we add a header to the data which which actually the data plus a header which is added by another protocol. So to go back to the definition of protocol suite, this is a protocol suite. These are a group of protocols that interact together in order to perform certain function. So these protocols are interacting together, are collaborating together to perform the delivery functionality of this web content to the network and eventually to the other side, the receiver. Okay. The decapsulation is the reverse process, clearly. It's the process of, again, extracting the data from the protocol data unit, and then we take the header, we take the information from the header, we process the data according to the header, and then we throw the header away, and then we send it up in the stack, and then it goes to the next layer, which again will extract the header from the data, process the data based on the information in the header, and then it sends it up and so on, until we get to the actual content, which again which then will be displayed on the screen for the user. Okay.
So this is so the encapsulation is done when it's coming from a server, maybe.
Yes, the encapsulation is done when the content is being sent from the server to the client, right? And then the decapsulation will be performed at the client side. When the client receives the content, it decapsulates the information until it gets this content, which will be displayed on the screen. That's a good point. Okay. So an example of a protocol, which is, of course, this is one of the most important protocols that's dominating the internet by all means, which is the internet protocol, or the IP. As we said before, all types of networks now is converging towards IP. So IP is a network layer protocol. Okay, so that's why we have, before it we have TCP and we have HTTP. So HTTP and then TCP and then the IP. The IP is the network protocol. After that there is the data link layer header. Okay, and then physical layer, it deals with analog signals.
What's the data link?
Data link layer is responsible for the exchange of data within a LAN, within a local area network. So the switches they deal with data link layer, and we'll talk about this in details. Don't worry. For now, we're just as we said, the strategy of the material here is that it gives you the high-level picture first, and then you start digging into details. Okay, that's a different approach from what we used to teach this course like 3-4 years back, where the first thing that we would talk about is the analog signal. So we start from bottom up. So the first lecture you deal with analog signals. So you know what analog signal is. So you know that the end outcome, what actually goes on the median, without actually knowing what is the purpose of this. So for some people this is a bit confusing. I want to always be motivated. Why this thing is important before actually I get into it or study about it. So this approach is usually, personally, this is the one that I like. So first you have to be motivated about what you are going to study before you actually study it. Okay? So this header, we'll talk about it in details. You will know every single field, what it does and what is the purpose of this, what it actually used for. Okay? So the IP, the IP header is where the address of the host or the sender and the receiver would be. Okay, so here we have the source address and we have the destination address. So that exists in the, so you can think of this as, you know, for the example that we just talked about. You want to send a letter to someone, so you put the data or the content inside the envelope and you put the address. And usually you put your address, the source address, and the destination address. Why do you put the source address? Yeah, so if there is any error, so that's exactly the same thing. So if there is any problem in delivering this information to the other side, we have some idea how to return this back to the sender, or at least inform the sender that this data has been sent incorrectly, so please send it again. Okay? So the internet protocol, or IP, is responsible for delivering the data end to end. So routers, they deal with IP protocols a lot. Okay? So routers are the ones that deal with IP, and we'll see the interaction of these protocols, what actually protocols are being used in every single device, because not every single device uses all these protocols. Some of them, they use only data link layer and they stop at this level. Routers, for example, they use IP, but not up above that. So routers do not understand what TCP is. They have no idea what TCP is. Okay?
They consider it as data because
They consider it as part of the data, and this is a content. For me, it's an abstract content. I don't know what this is. I don't understand. Okay? It's like you're talking to another person with a different language. So they don't actually care about, you know, TCP, or they don't care about HTTP for sure. Okay? Then it goes to the host, and the host is the one that understands all these protocols. So it deals with data link layer, IP, TCP, and HTTP in order to display the content. Okay? And this process of encapsulation and decapsulation, as we will see in a minute, will be done in every single device. Yeah, so here you have to encapsulate something. You send your request, it goes to the server. The server will then encapsulate the content into using some protocols into a specific data, and then it gets sent to the router. The router will decapsulate, because if you understand IP, you have to decapsulate in order to get to the IP level, right? So if I'm here, I want to know the address. Okay, so I have to decapsulate until this stage in order to know what the address is. And then once I know the address, I will encapsulate again in order to send it. So you keep doing this encapsulation and decapsulation in every single device. And sometimes you decapsulate up to this level. Sometimes you decapsulate up to here only. According to the type of device we're talking about. Every single device understands specific protocol in a specific level. So it stops at this level. We'll see that. Okay. So these protocols, the protocol suite, as we have just talked about now, so TCP and IP and data link layer, all these protocols, they interact together in forming what we call a protocol suite. Each protocol has a certain format or a structure of the message. So, for example, IP protocol deals with all these fields. So this header contains all of this, excluding the data, of course. Okay? This header contains all of this. And the data is actually what? The data here is actually TCP plus HTTP plus data. This is what we refer to as data here. Okay? So everything else is just the IP header. And the IP header contains source address, destination address, time to live, and all these fields that we don't know what they do for now, but they are very important. So the process by which networking devices share information about pathways with other networks, and how and when error and system messages. So these fields are used when there is some type of error. What do we do? If we send the information over the network, okay? What is the actual limit for this data? So if it gets sent through like 20 routers or something, Does that make sense? Or that's an indication that the packet got lost somehow and it's not reaching to the destination. So I better stop at this level and inform the sender that, okay, I failed to deliver this packet. So that's the information that's contained in this header, and it tells you whether you are going in the right track or if there's something wrong, and if there's something wrong, what do we do, and things like that. And also the setup and termination, and by that we mean again the handshaking that happens at the beginning of the communication, by saying, okay, I want to communicate with you. Are you available? Are you prepared to communicate, and things like that. So this is what we refer to as setup and termination. So every single protocol has to provide some way of setup to if it's connection oriented, because some protocols, as we will see, are not using the connection-oriented concepts. So in that case, you don't actually set up anything, or you don't terminate anything. You just send some packets, and that's it. And then you have to also handle the error situation. If there is any error, you have to know how to detect that error and how to deal with it. Whether you want to deal with it by retransmission, or you want to deal with it by correcting the information without having to do retransmission. So there are so many techniques and things that protocols have to deal with, and every protocol has set of things that it does, and based on that, it has certain advantages and certain disadvantages. So if I have to deal with every single issue of this, then my protocol will be very complicated, which means that the header will be very complicated, and the processing of this header will be very complicated, and you will have to spend a lot of time. So that will slow down the communication, right? And if I make my header very, very, very simple, and I don't deal with these issues, then okay, the delivery will be fast, but there is no guarantees. If there is any error, you won't have any idea how to deal with it. You will not be able to set up and terminate the connection, which means that you don't have, the data is not ordered, you don't have any control how the data is actually being sent, in which case there is high probability that this data can be lost and things like that. So there is some trade-off about how complicated your protocol is, what issues that you have to deal with, what issues that you can just push to other protocols you don't have to worry about, things like that. Okay. So based on that, so we have a protocol suite, which is a group of interconnecting protocols that perform certain function, and based on that, we have what we call standards. Standards is a very important issue because standards means that this protocol is now an international standard. What that means is that if you implement this protocol the way it's described in the standard, then your device will be able to communicate with any other device that's maybe manufactured by other vendors, okay, as long as you and the other device follow the standards. And this is a very important concept. This concept is revolutionary, or was revolutionary, in the sense that it facilitates multiple vendors to compete by implementing these standards into their devices, make their devices interoperable and being able to communicate with other devices. For example, Cisco routers, they can talk with D-Link routers as long as they implement the same IP protocol. Okay? So the standards are very, very important. Other than the standard, we call, if we use a certain protocol by ourselves without using the standard, then we call them proprietary protocols. Proprietary protocols are protocols that are not internationally standardized. Of course, many companies have proprietary protocols which they use internally for their internal use, okay, for testing and things like that, and they may use it actually internally, but it's not internationally used, okay? They can use it within their enterprise. But once they want to implement it in a product and make this product available, then it's better to use a international standard, so these devices can communicate with other devices that are manufactured by other vendors. So the concept of standards is very important. So there are some standard bodies or standard organizations. Okay, the most important ones are IETF, or Internet Task Force, Internet Engineering Task Force, IETF, and there is a website called ietf.org. So this website actually publishes all types of standards. So IETF, usually they standardize the protocols from the network layer and up. So all the protocols starting from IP, TCP, UDP, HTTP, all these protocols, you will find them published on the IETF website. Okay? Starting from the data link layer and down, data link layer and physical layer, the IEEE is the standard body. So all the 802.11, some of us are familiar with this number, 802.11 for Wi-Fi, or 802.3 or 802.3 for Ethernet, and so on. All these protocols for data link layer and physical layer, these are standardized by IEEE.
You mean they have made these protocols?
Well, yes. They coordinated the standard process. That does not necessarily mean that they have developed it themselves. What they do is that they make a call for a specific standards using some specifications. And this call goes to, for example, 4G. Okay? So 4G, fourth generation, for wireless, the ones that the one that we, most of us use nowadays. So what they do is that they make a call. Okay, we want to establish fourth generation standards with these specifications. And these specifications, they actually list it. We want a speed of at least this much. We want, if the car is moving with a speed of 300 kilometers per hour, it has to be able to communicate with a specific speed. Very detailed specifications. Okay? And they publish these requirements or these specifications. But they don't actually develop the standards themselves. What happens is that all companies, all the big players like Siemens, like I don't know, like many companies, they take these specifications and they start developing initially some proprietary, implementation of these protocols internally. They test it and things like that. And then they send to IEEE some kind of a, they call them a response to the specification. It's like a draft standards. Okay? IEEE, they take this draft, again, they go through certain iterations. We don't like this, we like this, things like that. Other drafts came from other companies. Okay, so we have to sit down together. Do we do it this way or this way? Okay, so both ways they achieve the requirements, but we prefer this over this, things like that. So they deliberate, they negotiate. Sometimes there is some political issues that come into the picture. Some company is more powerful than the others, the other company, so they enforce their way of doing things until they finalize the standards and they say, okay, we stamp, this is the international standard. So they publish it for everyone to use it and start implementing this. Of course, companies, they actually compete in doing that, because if they get their implementation through that standard, this means that they have a product right away before others, right? So once they stamp this as the standard, all of a sudden, I have a product. Other than the other companies will have to spend some time on implementation. So that's why companies, they compete into that. So the issue of standards and proprietary thing is very important. So we'll stop at this point.